Welcome to the Deep Dive. We're here to unpack complex stuff and really get to the heart of it for you. Today, we're diving into something pretty incredible that happens inside your own body. It's called the fasted state.
Hmm.
Yeah, our mission really is to understand just how precise your liver is and, frankly, how vital its role is in keeping your energy balanced, even, when you haven't eaten for hours, or maybe you're just asleep. And get this, how we actually define fasting here might surprise you. It's probably not what you think. Okay, so let's unpack this a bit. When we say fasted state, I imagine most people think of like long stretches without food, right? Days, maybe. So what exactly is this fasted state we're digging into today?
Right. That's a really important distinction to make up front. So biologically speaking, fasting actually refers to the state your body gets into about, say, 4 to 5 hours after you finished your last meal. And here's the interesting part. It also covers the state you're in when you're sleeping for, 7 or 8 hours overnight. What's really striking is that in both these situations, your plasma glucose, basically, your blood sugar level, it's kept incredibly stable, really precisely maintained, usually somewhere between 80 and 100 milligrams per deciliter.
Huh. So every night, basically, while we're asleep, we're technically fasting. That's kind of amazing. We're doing it all the time without even thinking about it. But okay, why? Why is keeping that glucose level so exact, like you said, between 80 and 100? Why is that so critical? What's the big deal if it drops or spikes?
Well, it's absolutely vital because you have several key tissues and specific cell types in your body that are almost entirely dependent on that glucose circulating in your plasma for their energy. They need it. We're talking about some pretty important players here. Your brain, obviously, your red blood cells, parts of your kidneys, the medulla, and even the testes. So if you think about the bigger picture, what would happen if these crucial parts didn't get that constant, reliable glucose supply? They just couldn't function properly, or certainly not at their best.
Right. That sounds, well, bad. Catastrophic even. So, okay, no food's coming in. How does the body, you mentioned the liver, how does the liver manage that? How does it keep fueling these really demanding tissues? It's not like there's just a big tank of glucose sitting there, is there?
Exactly, and that's where the liver really steps up and becomes the superstar of the show, you could say, keeping that blood glucose steady during fasting. That job falls entirely on the liver's ability to produce and release glucose. It literally functions as your body's own internal glucose generator, making it on demand.
Okay, so this is where it gets really interesting for me. How? How does the liver actually do that? It can't just like wave a magic wand, right? What are the actual processes?
No magic, no. But it is incredibly sophisticated. The liver uses two main pathways, two distinct ways to make glucose and get that plasma level back up. First, there's the sort of quicker route, breaking down stored glycogen. Glycogen is just glucose packed away for storage. So the liver breaks that down and releases the glucose straight into the blood. You can think of that as like the liver has a pantry, right? Quick access storage. Then there's a second, more involved pathway. This is where it actually synthesizes new glucose molecules from scratch, essentially. It uses smaller building blocks, often derived from the carbon skeletons of amino acids, parts of proteins. This is more like the liver running a sophisticated manufacturing plant, building glucose from raw materials when the pantry stock gets low.
Wow, okay. So it's got the ready-to-go snacks in the pantry and a whole factory making more. That's really efficient.
Yeah.
But is glucose the only thing the liver's churning out during this fasted state? Or are there other tricks up its sleeves?
Good question. And what's fascinating here is, no, it's not just glucose. While it's busy increasing its glucose output, the liver also ramps up its production of something called ketone bodies. This whole process is called ketogenesis. It's making an alternative fuel source. And why does it do this? Well, during fasting, the liver itself starts using fatty acids as its main energy source. Breaking down those fats produces a lot of this intermediate molecule, acetyl-CoA. And some of that acetyl-CoA gets cleverly diverted into making these ketone bodies.
Ketone bodies. So it's not just managing blood sugar, it's actively producing a second type of fuel, like a hybrid engine almost, offering different energy options.
That's a great way to think about it, yes. If we connect this all together, you really see the liver's central role. It's amazing. It provides both glucose, essential for those tissues that absolutely need it, like the brain initially, and red blood cells, and it provides ketone bodies. These ketones can then be used by other tissues, including the brain, after it adapts a bit as another energy source. So the liver basically becomes this central energy hub, managing and distributing different fuel types for the whole body when you're fasting.
Absolutely incredible. So just to bring it home for you listening, your liver isn't just some passive filter. It's actively orchestrating your body's entire energy strategy when there's no food coming in. It's working away behind the scenes, keeping your brain going, your blood cells working, all those vital systems running smoothly. And all this happens without you even having to think about it. So there you have it, a little peek under the hood at the incredible job your liver does. Maintaining those crucial energy supplies, keeping everything balanced, even during those, well, pretty common periods of fasting like every single night is happening far more often than you probably ever realized, right? So maybe next time you're settling down for the night or even just between meals, take a second. Think about that silent, complex work your liver is doing right now. How does knowing about this incredible, efficient energy management system, driven by your liver, change how you think about your food, maybe, or your sleep, or how adaptable and amazing your own biology is? Something to chew on, perhaps, until our next deep dive.